Welcome to G-Fun Facts Online. When we see a new skyscraper rise, we marvel at its creation. But what about the other end of the cycle? How do we unmake a giant? The process isn't a simple wrecking ball smashing into a wall. The deconstruction of a large structure, whether it's a skyscraper, a bridge, or a stadium, is a carefully choreographed dance of engineering, a feat of precision that often happens in the shadows of our bustling cities. Today, we're pulling back the curtain on the art and science of unbuilding. The term demolition often brings to mind explosive implosions and swinging iron balls. While those methods exist, the modern field is far more nuanced. It's a multi-phase journey that starts long before the first piece of concrete is broken. The first step is always project planning, defining the budget and timeline. This is followed by a critical structural survey. Engineers inspect every inch of the building to understand its design, its condition, and to identify hazardous materials like asbestos. This survey determines the safest and most effective way to bring it down. Next, a detailed demolition plan is developed. This document is the Bible for the project, outlining the exact methods, the equipment to be used, how debris will be handled, and most importantly, the safety measures. Speaking of safety, a comprehensive plan is created to protect not just the workers, but the public as well. And you can't just start tearing things down. A web of local, state, and federal permits must be navigated. Only after all this planning does the execution, the active demolition, begin. Finally, the site is cleaned, debris is removed, and after final inspections, the land is ready for its next chapter. Now, let's look at how this plays out with different types of structures, because each presents a unique engineering puzzle. Take skyscrapers. In a dense city, you can't just implode a 50-story tower. The risk to surrounding buildings is immense. The solution is a methodical, top-down approach, taking the building apart floor by floor. A perfect example is the former J.P. Morgan Chase headquarters at 270 Park Avenue in New York City. At 52 stories, it became the tallest building ever to be voluntarily demolished. The process began by removing hazardous materials. Then, the entire structure was wrapped in scaffolding and netting to contain dust and debris. A massive crane was erected to lower large sections to the ground. Inside, small demolition robots and excavators broke up concrete floors, while workers with torches cut through the steel beams. It's a slow, painstaking process, but it guarantees safety. What's more, this project set a new standard for sustainability, with an incredible 97% of the materials from the old building being recycled, reused, or upcycled. An even more futuristic method is the top-down way system, which uses a completely sealed platform that encloses the top of the building. As demolition moves down, the platform is lowered, containing all dust, noise, and debris. Now, what about bridges? Here, the main challenges are minimizing disruption to traffic and protecting the environment, especially when a bridge spans a river. Sometimes, for a remote bridge, a controlled explosive demolition is the fastest option, but this requires precise placement of charges to ensure a controlled collapse and is often restricted near waterways to prevent contamination. The more common method is strategic removal. This is like surgery. Large sections of the bridge are cut and removed one by one. Engineers must constantly analyze the structure to ensure it remains stable as pieces are taken away. A major hurdle is dealing with post-tensioned concrete beams, common in modern bridges. These contain steel tendons under immense tension. Releasing this tension must be done carefully to prevent a sudden, catastrophic failure, often by drilling to selectively de-stress the tendons in a controlled sequence. Then we have stadiums. Demolishing a stadium can be a public spectacle. Because they often have a large footprint and are somewhat isolated, they are prime candidates for implosion. A well-executed implosion can bring the entire structure down in seconds. But it's not the only way. Mechanical demolition with a fleet of high-reach excavators armed with hammers and shears is also common. And sometimes, selective deconstruction is used, especially when parts of the stadium, like seats or signs, are salvaged and sold to fans as memorabilia. The most complex deconstruction project of all, however, is a nuclear power plant. This process is governed by extreme safety regulations and can take up to 60 years. The first, most critical step after shutdown is removing the nuclear fuel from the reactor core. Then begins a long phase of decontamination to remove radioactive materials. Only then can dismantling begin. There are two main strategies. Decon, or immediate dismantling, starts shortly after the plant shuts down. The other is SAFSTOR, or safe storage, where the plant is monitored for decades, allowing radioactivity to decay to safer levels before dismantling begins. This reduces worker exposure and the amount of radioactive waste. Finally, let's go offshore to oil rigs. Decommissioning these giants is a legal requirement to return the marine environment to its natural state. The process can be as complex as the original installation. The topside, the operational part of the platform, can sometimes be removed in a single massive lift. More often, it's dismantled in smaller sections. The real challenge is removing the jacket, the huge steel frame supporting the topside, which is mostly underwater. This requires divers and specialized tools like diamond wire saws or abrasive water jets to cut the structure into manageable pieces for removal. Underlying all these methods is a deep understanding of structural science. Engineers use sophisticated modeling to prevent what they fear most, a progressive collapse. This is a chain reaction, where the failure of one part of the structure leads to the collapse of the whole thing. By running simulations where they virtually remove columns, they can predict how the load will shift and ensure the remaining structure stays standing. They also use vibration monitoring, placing sensors around the site to measure ground tremors. If vibrations exceed safe limits that could damage nearby properties, the work stops immediately. Looking to the future, technology is making deconstruction safer and smarter. Demolition robots are already here. These remote-controlled machines can go into hazardous areas, keeping human workers safe. They are precise, efficient, and can work around the clock. Artificial intelligence is also entering the field. AI algorithms can analyze building plans to create optimal demolition strategies. AI-powered computer vision can even sort debris on-site, dramatically increasing recycling rates. This all leads to a larger idea: design for deconstruction. This is a shift in thinking, where buildings are designed from day one to be easily taken apart at the end of their lives. This means using bolts instead of welds, choosing recyclable materials, and keeping detailed records. It's the key to creating a truly circular economy in the construction industry. The unmaking of our largest structures is a hidden world of high-stakes engineering. It's a testament to human ingenuity, where the end of one building's life is not just destruction, but the carefully planned beginning of something new. Thanks for tuning in to G Fun Facts Online.